This is another experiment drawing shear force diagram and minimum diagram for overhanging beam subjected to point loads. And you can see this diagram. It consists of 4 point loads acting at different positions in an overhanging beam. 400 newtons, 300 newtons, 800 newtons and 500 newtons. We will try to solve this problem using Ansys Mechanical APDL software. Go to Preferences, take Structural, Preprocessor, Element Type, add Beam Element, 2D Finite, and go to Options, and in K3 select Linear Form. Why? Because the points loads are acting on the beam. Then close this one. Then go to Material Properties, Material Models, Structural, Linear, Elastic, Isotropic. Give the Young's modulus 2E5, Poisson's ratio 0.3. Click OK. Then after giving the material properties, go to Sections, Beam, Common Sections, give the breadth and height of the beam. Height of the beam is 20 mm, breadth of the beam is 10 mm. Click OK. Then after defining the cross section, go to Modeling, Create Key Points in Active CS. Key point 1, 0, 0, 0, apply. Key point 2, it is 500, 0, 0. Key point 3, 1000, 0, 0. Key point 4, 1500, 0, 0. And finally key point 5, it is 2000, 0, 0. Click OK. Then the key points are generated. After creating key points, join these key points by using line command. Lines, go to straight line and select all these key points. Click OK. Then the lines are constructed. After constructing these lines, we need to discretize these lines into various elements. Go to Meshing, Size Controls, Lines and Picket Lines. Give the number of divisions as 5. Therefore, each line is divided into 5 equal number of divisions. After dividing these lines, we need to mesh. Go to Mesh, Lines, select all these lines, click OK. Then the meshing operation will be finished. Now it is ready for applying the boundary conditions and loads. Now plot key points. Then the key points will be displayed. Then we need to give the boundary conditions. In order to give the boundary conditions, go to Loads, Define Loads, Structural, Displacement on nodes or key points. Displacement on nodes. Select the first node, give all DOF OK. Therefore, the first node is constrained in all directions. Then force on nodes, give the second node, and Fy value is how much? Minus 400. Apply. Then select the third node, and it is minus 300 newtons. Select the fourth node, it is minus 800 newtons. Click Apply and select the fifth node, it is minus 500 newtons. Then after giving the loads, now the problem is ready to solve. Create lines. Now it is finished with all the loads and boundary conditions. Now it is ready to solve. Go to Solution, Solve, Current LS, click OK. Now the solution is done. Then in order to view the results, go to General Processor, Plot Results, Contour Plot, Nodal Solution, and here select the displacement vector sum. Then you will be able to see how the deformation takes place in the overhanging beam against the given loading conditions. You can see here the red color at the end of the beam is more severely stressed against the applied loading conditions, and the deformation, it is observed to be 9069.76 mm. It is the maximum deformation encountered in the beam. To view the stresses and forces distribution, type set, L step in the dialog box provided at the top of the window, then click enter. Then go to general processor, element table, define table. Here give shear force diagram. I wanted to see the shear force diagram distribution. SFD, SMISC 5, SFD 1 by sequence number 18. 5 and 18 will give you the shear force distribution. Then select BMD by sequence number SMISC 2, apply. Then again select BMD 1. I'm giving different names. BMD 1 is at jth node. As by sequence number, it is 15. Click apply. 5 and 18 are related to shear force. 2 and 15 are related to bend moment diagram distribution. Therefore, in order to view the results, go to plot results, contour plot, line element results. Then I can view the shear force distribution SFD, SFD1. Then if you take the undeformed shape, then you'll get the shear force distribution. If you want the deformed shape also, you'll get the shear force distribution, how the deformation takes place. So it is a overhanging beam. See here how the deformation is encountered in the beam. This is the shear force distribution in the figure. If you wanted to view the bending moment diagram, then take the bending moment diagram, select the bending moment diagram and click OK. You can see the how the bending moment diagram distribution is observed in the entire cross section of the beam. And the maximum value of the bending moment is also observed from this figure. You can note down that value to determine the bending stress induced in the beam. You can also check that value, calculate the bending stress analytically, and check that value with the Ansys results. And here you can see here, this is the bending moment diagram distribution. Okay, in this way you can calculate for different types of beams. Here we have taken the overhanging beam and we have noted down the deformations, shear force distribution and bending moment diagram distribution for point loads. Similarly, we can also do it for the remaining cross sections also. We can also see the animation of the figure using plot controls option. You can see the animation of the figure. Thank you for watching this video.